Hello everyone, welcome back to Hood's Computer Science project. In this new video we will finish our code that will create our first deep learning model. In the last video we saw how to take the pictures from the computer and create a dataset with that. So in this video we will take this dataset and create our deep learning model. If you're ready, don't forget to subscribe, activate the notification and like this video if you are enjoying. And let's get started. But before that, I have an announcement to do at the end of the video, so make sure that you watch the video until the end. Now we can jump to the computer and let's get started. So here we are, it is always the same notebook as the last video. So the first step of this tutorial is to add the libraries and package that we will need to create the deep learning model. So first of all, I have import TensorFlow as TF. And to make this work, it is like OpenCV, you need to install it via the pip install in the terminal of your computer. Then we have the sklearn.model selection import k folds. From statistic import everything. I think you also need to import statistic from the terminal with the pip install. And finally, we will have all of this. These are all from Keras. So you also need to install Keras via the pip, but I think you need first to install TensorFlow because Keras is using TensorFlow in backend. So we have keras.utilities to categorical, keras.model sequential, keras.layers tensors and flatten, and then we have keras.optimizer import SGD. And finally, we have sklearn.metrics import accuracy score. So I don't think we will use all these libraries, but just for now, we make sure that we have everything we need. So after that, it is the same as the last video: image path, categories, training data. We have the definition that creates the array list with the image and associated with the number. And then this method prints the length of the training data, so we know how many pictures that we are dealing with. Okay, so now I have added all this bit of code, so let's go and have a look at it. So first of all, we have a variable that is the image size, and I have put it in 60. Why did I choose 60? Because the images are 60 pixels by 60 pixels, and we need to put the same value for the reshaping, but that is for this method. Let's first look at here. So we create an array, capital X, we call us this, just to say that it is an empty array. Then we have the array Y, which is also an empty array. And then from features, comma, label in training data, we have, so what are we doing here is to take the elements in training data, because if you can remember, in the training data, we have elements which are composed themselves by two elements, the images and the value that they are associated with. So the features is in fact the image, and the label is the value. So we add to X the features, the pictures, and then in Y we associated the label. And then this one is very important. X equals to np.array X. So we transform the array with the numpy, and we need to reshape -1, image size, so that's the dimensions of the image. So that's why it has to be the same dimension as the original image. So that's why I chose 60, because the images are 60 by 60 pixels. So that's 60 and that's 60. Everything is alright. Then we have comma and 1. And then we have X equals to X.type as type float 32. So we're transforming every pixel value in the image into floating numbers. And then we divide every pixels in the images by 255. So why we are doing that? It is simply because as it is a binary image, we have two possible values: 0, which is the color of black, and we have 255, which is the color of white. And when you are dealing with deep learning, it is better to deal with value between 0 and 1 rather than 0 and a big number like 255. So we are dividing every pixel value by 255. So if we have a 0, a black pixel, it will be 0 divided by 255, and it will still be 0. However, if we have a white pixel, the value will be 255, and if we divide it by 255, it will give us a 1. So with this, we can have only two values, 0 and 1, instead of 0 and 255. And then we have the y equals to np array. Well, we don't have to reshape everything because the y array, it doesn't contain any image. We don't need to modify it more. Okay, so that is the first part. We do a transformation of the array, and then we create our model. Okay, so first we create a variable, model equals to tf. So remember, tf is the abbreviation of TensorFlow here. Import TensorFlow as tf. Then we have .keras.model sequential, and then we need to follow all of this. We need to write all of these codes. Model.add tf.keras.layer.flatten. Then we have model.add tf.keras.layers tense 128, and activation equals to tf.nn.relu. So we are creating a new layer in the deep learning model, and then we create a second one here, and then we create the ends of the last layer, which is the output. So that is why we have 10 outputs. Then we have the model compile optimizers equals Adam loss, and then we have model compile. So that will print all the accuracy and the loss and the optimizer, so we can have a visualization on what is going on. Then we have the model fit x and y. So x is the input array and y it is the output array, and we know that they are associated with together because it is supervised learning. Then we have the epochs equals number 5. So I try to fit and refit over again 5 times in total. And then we will save it into an H5 file, call it Sudoku _model _YTB. So let's test it. So let's go to kernel, restart and run all. Yeah, okay. So we can analyze it. So first of all, we saw that the loss is quite big, 2.6, 2.3 on 1.8. Well, the loss is decreasing, but it's still not enough, and the accuracy is terrible. Is at 0.5. Well, it was 0.7 in the last epoch, but if it decreased, that means that the model is not very good. And there are multiple reasons for this. So first of all is not enough data. Of course, we have 10 images, and each type of images has only one instance. We have one instance for the 0, one instance for the 1, and that is completely not enough at all. In order to do that, we need at least 1,000 image per number, so we get 10,000 slightly different image to get the data bigger. Well, it seems to be a big number, and actually it is. But don't worry, Python can change slightly the images, so we can go back to the Jupyter notebook where we save the images in the computer. So we can go to that code, and instead of saving one image, we will save 1,000 images by changing them slightly. So that is why we will do it in the next tutorial. So that was it for this video. Thank you for watching it. So as I said a few seconds ago, in the next video we'll see how we can slightly change the images when we will save them in the computer. So here's my announcement. I have recently been asked if I could make a video explaining how to change the background without a green screen like I do. After that, I thought that it might be a good idea to make a Q&A video. If you want to ask some little question about, for example, my projects, so just write yours in the comments below. And of course, I will talk about this idea of how to change the background without a green screen. So thank you to you for asking this if you are watching this video. And that was it for today. Don't forget to subscribe and like this video if you enjoy it. Don't forget to check the link of the notebook in the description below. And see you in the next video.